Bye-bye.
Hey, hello and welcome everyone to Where Could Your Degree in Chemistry or Biochemistry Take You, our online event, which is part of our exciting new online series exploring the fantastic career options available to you as a University of Southampton graduate. My name is Devika and I'm currently in my final year of BSc Biochemistry degree, and I'm also a student at the University of Southampton. Recently, I finished my labs from lab dissertation project on PDX1 enzyme, which is basically an enzyme for vitamin biosynthesis. And I have also applied for a few graduate jobs, and I'm hoping to apply for a master's in biochemical engineering. So the University of Southampton is passionate about the degree it offers and helps students find exciting and inspiring careers. This event gives you a chance to hear from amazing recent graduates in your subject area as they talk about the experiences and how they have used the degrees to positively impact their careers. We would love to hear your questions for our speakers or for me, so please put them in the Q&A and we will go through them at the end of the webinar. You can see which questions have been published, so go ahead and like the ones that you want to be answered and we should go through those first. You won't be able to have our cameras or mics on during the session, so please direct anything you want to ask straight into the Q&A chat. Without further ado, it gives me great pleasure to introduce you to our speakers, Jamie Purkis, who studied chemistry, and Ian Dragomir, who studied biochemistry. So guys, first of all, would you want to introduce yourself? So first of all, I'm going to go for Jamie. So Jamie, introduce yourself. What do you do?
Hi everyone. I can see there's 104 people online, so afternoon even. Yes, I'm Jamie Purkis. I'm a nuclear waste consultant with an engineering firm called Atkins. I'm based in Bristol. I completed my master's degree in chemistry from Southampton in 2015. Then I went on to do a PhD in chemistry at the University of Edinburgh in nuclear chemistry in 2019. And then after that, I wasn't quite sure what I wanted to do. So I stayed in university. I moved back down to Southampton to do a research fellowship in nuclear decommissioning from 2019 to 2021. And then I joined Atkins in 2021. And I now help take down nuclear reactors. So I use my degrees in chemistry and then nuclear chemistry, my PhD, to advise governments. I've advised governments, companies around the world on how to safely remove some of the most hazardous chemicals in the world. That's uranium and plutonium.
Thank you, Jamie. Also, what do you enjoy about your job? How is it like? Is it quite flexible? Is it a 9 to 5?
It's almost a bit cliche to say this, but not all chemists wear white coats. The stuff that I enjoy is the flexibility. So, for example, I'm working with a client at the minute, Rolls-Royce, who deal with nuclear submarines. They do small modular reactors. I mean, in addition to building aircraft and weapons and all the rest of it. And so one of the key clients that we've got at the minute is working with them to help them make essentially the next class of nuclear submarine. And I was doing that for a couple of days last week, as well as I was working with a company called EDF, who own a lot of the nuclear power stations in this country. You may have seen, well, a lot of the audience I hope have seen on the news recently that 2 new nuclear power stations have got the go-ahead in the last couple of years. That's Hinkley Point C, which is about an hour's down the road from me and sort of that way, and one over in Sizewell C, which is East England, Kent or Essex, I think, over that way. And so I help EDF. I help tell them essentially what the different classes of the fuel that has to go into the reactors. So everything from the amount, the enrichment. Appreciate not much I can say publicly, just the nature of the job, unfortunately. But to answer your question, it's the variety. Every day brings something different. Every day I'm asked as an expert in the field, what about this? And so from one day to the next, I'm doing 2 things that are completely different. Nuclear submarines and nuclear reactors they may sound reasonably similar, but they're worlds apart. So it's a variety.
That's amazing. It's good to have a variety. And also, Ian, again, what do you do? Like, how's your job? Is it quite flexible? Is it like a 9 to 5?
Good afternoon, everyone. My name is Janus Dragomir, and I am a data scientist. I have graduated from the University of Southampton in 2019 with a degree in biochemistry, which was then followed by a master's in bioinformatics at the University of Birmingham. That was also followed by a short internship where I have worked for a personalized cancer treatment with a company in Cambridge. And then the COVID-19 pandemic hit, unfortunately. And that was the point when I moved to Charles River, and I have worked as data scientist, basically trying to improve the testing capacity of the UK at that time, which was then followed by the almost couple of years now working for Achilles Therapeutics, where I have done personalized T-cell therapies in cancer clinical trials. Now, regarding your question regarding my day-to-day job, I would first like to say that it's a very exciting thing that no 2 days are the same, in the sense that you may have different biological or scientific problems, if you want, that you may have to answer. You can regard it as a 9 to 5 job if you want. However, that only applies to my most recent role at Achilles Therapeutics. Whereas for Charles River, when I have worked for the COVID-19 pandemic, we used to have a shift pattern. So that can depend depending on the sort of research that you're contributing to, and also depending on if you're working in academia or in the industry. And I would say probably the most exciting thing after the fact that no 2 days are the same is the ability and the option to interact with top researchers from all over the world and basically contribute to the scientific community and finally improve the patient outcome, which is the final goal that we have as scientists.
That's amazing. Also, I wanted to ask Jamie, what has your career highlight been so far?
Oh, good question. The highlight, I don't know if people are on this call old enough to remember Fukushima. I suppose it probably would be. What are we going back to 2005? So yeah, so Fukushima was it was a big Japanese nuclear disaster in 2011, and I was lucky enough to go out there just before COVID hit. So in February 2020, so about a month or so before we all shut our own homes. But the highlight of my career was going out to Japan, working with Japanese out there to advise them on exactly what to do with vast amounts of their radioactive soil. So yeah, that was quite cool. I mean, I speak no Japanese, so it's all had to be done through an interpreter, which was quite fun. Some technical terms being lost in translation. I got some confused looks every now and then, but that was really fun. Going up there just after finishing a PhD, thinking I'm advising governments. So that's where a degree in chemistry can take you, to Japan to help advise the Japanese government on what to do after a nuclear reactor meltdown.
Wow,
that was really cool. I really enjoyed that.
That is actually really cool. Like, I would love to do something like that.
Well, that's where a degree in chemistry can take you.
Yeah, exactly that. Yeah. Also, Ian, like, what do you enjoy the most? And also with like bioinformatics, I have done a module in bioinformatics, and I wanted to ask, how was your master's in bioinformatics? Because I was considering that first.
That's a very good question. And I think it's also related to the previous question for Jamie, which was the highlight of his job. So first of all, what cemented my decision to do a master's in bioinformatics was one of the projects that I have done with one of my professors at the University of Southampton, that is Dr. Neil Smith. Pretty sure most of you know him. And that basically got me into big data analysis, and how to streamline analysis and apply all these vast amount of data sets to answer a biological problem. That sort of cemented my decision to join the Masters in Bioinformatics. Now, during my Masters in Bioinformatics, that's when I understood how vast this area is. And nowadays, I would say that all biology is computational. We're generating huge amounts of data, which at some point has to be analyzed, and we have to derive an insight from it, because that's the main point, what you get out of the data. So an interesting point here is, as well as one of my highlights in my career, there are a couple of points I would like to mention. First of all is the point when I have joined Charles River, and that's the point when I realized how can you use a degree in biochemistry plus the skills in bioinformatics to contribute to the COVID-19 pandemic. And what really helped me is, first of all, the lab skills that I have developed at Southampton, including PCR. And I'm pretty sure everyone knows that PCR is now unfortunate due to the COVID-19 pandemic. And second of all, the ability to analyze huge amounts of data which impact the day-to-day life of someone. So for example, you need to make sure that when a test is positive, you want to make sure that it's really positive. And when it's negative, you want to make sure that's a true negative as well. So just the idea of being able to contribute to both sides of skills, that is one on the wet lab side and the other one on the dry lab data analytics side, was really what showed me the power of bioinformatics, which was then followed by my time at Achilles Therapeutics, where I have got the chance to contribute to two very important clinical cancer trials. So yeah, that's basically sitting at the top edge of science and applying new sort of personalized treatments with the use of data in order for them to make them more personalized rather than just trying and implementing a general solution which may or may not work for that specific patient.
It's like amazing how bioinformatics is literally like the most useful thing now. Like a lot of people really want to go into it. Now we're going to move on to like, you know, your background. So like, what did you study at school, like in terms of A levels and GCSEs that kind of like drove your career? I'm going to direct that question to Jamie first.
Sure, yeah. What drove my career was science. I love understanding how the world works. Whether it's, for example, I remember one of my fondest memories was out walking in the forest, and I thought, well, why are trees green? And or why does it rain? Or what makes rainbows the color that they are? And the beautiful thing about the universe is that you can actually understand it through science. And if you understand it, you can help make the world a better. You can help make the world a better place. For example, cancer therapies. For example, cleaning up nuclear waste after a disaster. So a lot of my journey, if you like, has been dedicated to understanding how the world works. So at school, I did. Oh God, it's gone back a few years now. I came out of school in 2009. So this is going back 14 years. God, I feel old. But at school, I did science, I did double science, I did maths, and those were the two most important subjects, I would say, at school, is making sure that you've got a firm understanding, a firm grasp of your science and your maths. And I see Ian as, nodding, yeah, it's maths and science, because chemistry is a very numerate subject. You need a firm understanding of the maths behind it to understand, for example, physical chemistry, why certain things work, like NMR spectra or IR spectra, to understand the physical processes behind the analytical results that you get. That's very important. And so for my A levels, I did physics, I did chemistry, and I did environmental science, because I wanted to couple the chemistry and the physics together, but I also wanted to understand how the natural world worked. So when I was deciding which university to go to, I was looking at two subjects, either environmental science or chemistry. And in my mind, they're more or less the same thing, because they both, or the chemistry that I undertook, the type of chemistry that I undertook is really dedicated at looking at how the world works. I don't have much to do with the living world because I'm not a biologist. I dropped biology as soon as I could. But chemistry and physics are two really important subjects, and having that second science when I was in my first and second year really helped me understand, for example, some of them, because I didn't do A-level maths, and I wish I had, because physical chemistry and quantum chemistry in particular involves a lot of maths. And so I had to rely on my GCSE, which was all right, I was okay, but I would really encourage those in the audience that still have to pick their A levels, or even doing GCSEs at the minute. Focus on your maths, focus on your numeracy skills, because that's where a lot of people, myself included, found it harder going into the second year, as things became more interesting but more challenging at the same time. And one of the things that, particularly over a lot of other courses I've focused on Southampton, is that they train you in the first year when it comes to maths. I don't know if it still was running when you were there, but in my first year, so this is going back 12 years now, 2011, 2012, there was a course specifically in maths for chemists, recognising the importance that maths has on that second and third year chemistry, physical chemistry in particular. So obviously if you want to go and study chemistry, it's important that you do it at A level. I would say a second science, physics or biology, but focus on your maths and make sure that you've got a numerate subject. If it's not physics or not on maths, computer science would also work. And I used to do a lot of outreach. I still do in my current job, but when I was back about 18 months ago, I used to help with admissions for ocean and earth science. And one of the things we used to look for was that supporting science, because it gives applicants, potential students in the subject, that well-roundedness, because chemistry doesn't just do chemistry. It pulls in biology, it pulls in physics, it pulls in maths, it even pulls in some geography, some history as well. And computer science, increasingly, and I'm an old fart, I'm 30 this year. Computer science, it confuses me a bit, but to have that level of supporting knowledge, computer science, and I'm sure the two of you will be able to talk much more about that, about the importance of computer science and even coding and data science.
Yeah, no, I totally agree with the whole like how maths is so important, because I didn't take maths as an A level. I took psychology, chemistry, and biology because initially I wanted to go into forensics. So I thought of my career before I thought of what course I wanted to do at university. And then now thinking of like going into like a master's that does require maths, I feel like I did leave out on like the maths element. But like I said, I feel like it's good to take maths, but also like, you can teach yourself. There are like other courses and modules that you can take online during your uni course. And sometimes like Southampton does offer like, extra like maths modules for you to take. So yeah, but for me, I found it difficult in like the maths part of like the degree, because I obviously did not take it. But there wasn't as much maths in biochemistry than I think chemistry.
So when you did biochemistry, did you do quantum chemistry as well? Have you done modules in quantum chemistry?
No. It was very much like more biology orientated than chemistry.
Sure.
So but now because I'm going to go into like something like I'm applying to a master's that is very much like more engineering side, it requires for me to have those math skills that I don't have.
To be clear, you can do, and people often succeed, greatly succeed in doing chemistry at degree level without having a solid maths background, because Southampton teaches it. It's not essential, but it helps. And I would say, as I said, if you've not got maths proper, having that other numerate subject, physics, engineering, computer science, data science, again, that will set you up. It will make things a lot easier if you've got that appreciation of because chemistry it's a numerate subject. And the very foundations of chemistry, spectroscopy, for example, a lot of spectroscopy, and I have a lot of your audience cover spectroscopy, will understand exactly how important, for example, the Fibonacci sequence or Fibonacci or Pascal's triangle. This is where not having a maths background, this was 10, 12 years ago, but having that appreciation of maths, for example, it helps with NMR, and it helps with quantum chemistry. It helps understanding X-ray spectroscopy, for example, which is so important when it comes to characterization of, for example, proteins. So, and if you have that maths background, then you can understand the fundamentals more easily. And so the applications and the interpretation of results, which is because chemistry is also a practical subject, you make a compound, you don't know what it is, you analyze it by NMR, and you get the data back. And being able to interpret that data when you're dealing with a compound, because I'm a synthetic chemist, I'm not a computational chemist. When I made a compound and I wasn't sure what it was, having that numerate background helped, for example, with the IR spectra, or the NMR spectra, or the crystallography. It just made everything run more smoothly. Which isn't to say that you have to have it, but it helps. And I don't want to put the audience off because I didn't have A-level maths, and I graduated, I think, certainly with a first-class degree, and it was fine, but it would have helped. Does that make sense?
Yeah, thank you, Jamie. I also want to ask the same question to Ian, like, as in, like, what did you do at school? Like, what, like, made you want to go into, like, data science?
Yeah, that's a very good question, and I agree with 99% of what Jamie said. So I was very centered in high school. Basically, I've done natural sciences with a high focus on chemistry. And basically, when I wanted to go into do an university degree, I was sort of in between forensic science, analytical chemistry, and biochemistry. The reason why I picked biochemistry is, first of all, I thought it's sort of a middle ground and I can sort of evolve from there if I ever choose to go more on the chemistry side or focus more on the biology side. What I have discovered is basically I got really, really interested in how to apply biology, but with computational means, because I realized you need to scale things up. And at some point, everything will scale up. And that cemented my decision to, as I said, to go into the bioinformatics data science thing. And I really, really cannot stress enough how important maths are. Now, I have to say that even without a maths background, things can be learned, not only at university and at your master's degree or internships, but also on the job. So you may find that for a specific job, which I found as well while working for Charles River, I just realized that I need a bit more maths, and you can still learn it. That's probably loads of development opportunities in this specific area. But I think, yeah, maths are really important, and also pick an area of science and try to basically cover as much ground as possible just to get like an overview of everything around. But at the same time, try to go in depth into one specific area. Just think of it like a T-shape, basically. Trying to specialize yourself in a specific sort of subfield if you want, but have a broad understanding of everything that's going on. And that's what really, really helped me. And I've done that at university, trying to get a bit of everything and just understand where would I like to sit in this grand scheme of things, which is constantly expanding. Like there are new fields emerging once every couple of years. You'll see new sort of fields being merged. For example, no one would have thought about data science and bioinformatics roughly 30, 40 years ago, even though all the other sciences, they were sort of there, but not to this stage. So yeah, I would definitely go with pick one area of science, do as much as you can. Some of things you will forget, but some other big chunk of data will stick with you. And that's really going to come in handy when you're going to work either in academia or in industry.
Thank you, Ian. Like, I totally agree with the whole, like, how data, like, right now, a lot more people do want to go into data science. And like, for me, like, what got me into like bioinformatics was because I did like a little mini like coding course and I really enjoyed it. So I think don't be scared of taking new opportunities. It's always good to, like, you know, just learn as much as you can from like different areas. And like, yeah, like you said, it's good to know, be more well-rounded than just know one specific thing.
Something else which I would like to add, sorry for interrupting, because you mentioned programming. I must say I had literally no programming background whatsoever from high school or middle school or anything like that. And I basically took up a course which was called Introduction to Bioinformatics. I'm not sure if it's still being run. And I remember being there at the first lecture where they presented Linux and basically how to interact with a shell, which was Bash. And then they also spoke about the R programming. How can you use R programming to do some data analysis? And I remember I was basically clueless. I had literally no idea what was all that about. And I basically had to start from zero. And without any background in computer science, it can be easily done, I would say. As long as you put the effort in and as long as you're keen on learning a new skill, it can be done.
Perfect. Now I want to move on to like how your time was at Southampton. So pretty much just, you know, like, was there a particular moment, event or activity or society which inspired you? I'm going to ask Jamie first for this question.
Yes, there was. And that was, I don't know if it's still called it, but it was called SOTSEF when I was there, the Southampton Science and Engineering Festival. And I used to help out. I'm seeing nods, so I guess it's still running. But I used to do quite a lot of volunteering with going to schools and talking about outreach and stuff. And the usual reaction for people when they hear you studying chemistry is, oh, that's quite interesting. Chemistry is quite a difficult subject, which it is. But the moment that really stood out for me at Southampton was being able to have those conversations with young children, families, with young kids, and it was to inspire the next generation. And there was a moment when I was explaining, I think he was not been older than 5 or 6, and I remember explaining about light, photochemistry. So light is obviously important to chemistry, and I was explaining about how light works, which you might think is a bit physicsy, but light, for example, used in UV spectroscopy. So understanding light is an important aspect of science. And I was explaining how a rainbow works, and we've all seen the double slit experiment and diffraction or refraction through a prism. And there was this moment when this young kid, his face lit up like a Christmas tree. It was like light. I get how light works. Mummy, this is how light works. And that just stuck with me. That because I've been to science festivals because my mum and dad used to take me to science festivals all the time, and being on the other side of the desk, being on the other side of the table, actually doing the explaining, was magical, quite frankly. And Southampton, obviously I can't speak for the universities, but Southampton places a big, certainly in my experience, places a big importance on not just teaching its own students, but making sure that the science that is taught is accessible to the public. And that's, yeah, I'm seeing big nods from both of you. Yeah, so for example, my old boss is now the president of the Royal Society of Chemistry, and she's won a host of awards for going out and talking to the public, and that was one of the reasons why I chose Southampton. Is because some academics, myself included, are a bit stuff. We like to talk amongst ourselves about things that don't really actually matter to the public. People about things that are a bit academic. But Southampton, in my experience, and one of the reasons I chose it, is because it gets you out of the box. It gets you out of the ivory tower, and it gets you talking to the public. And so that for me was the breakout moment at Southampton, and it was the reason why I thought, yeah, I've made the right choice coming to Southampton. Because most Russell Group universities, the teaching, the quality of research is more or less the same. It's, you know, there's not going to be a huge amount of difference between universities in the top 20. I mean, they're all pretty world leading, but it's and so I was looking for something a bit more than that. I was looking for what sort of university gives back to the community. What sort of university isn't afraid to open its doors and gets people through the doors and gets people talking about science, because that's why I'm a scientist. Is to not only understand the world, but to use the science, use the knowledge and the skills that I've got to help other people who aren't scientists for whatever reason, who either don't get it or don't like it or fine, whatever, is to get out there and help people understand science. Because if you understand science, you can understand the world around you. And if you understand the world around you, you can help make it a better place. Which sounds a bit twee, I know, but that's important to me. And that was the reason why I chose Southampton. Is because of that feeling of, yeah, they get it. They get that science isn't designed to be, chemistry in particular, isn't designed to be constrained to this academic department with lots of old stuffy professors with weird hair talking about chemistry amongst themselves. It's about getting out into the public. So that's the breakout for me.
Perfect.
Sorry,
It's fine. It's all right. I also want to ask the same question to Una about, like, why did you choose Southampton? Like, was there any like societies that, you know, kind of like made you want to kind of go into like the field that you are in?
I feel like Jamie already answered 80% of the question for me. So yeah, I knew that Southampton put a lot of emphasis specifically on seminars, conferences, and anything related to science and research. And that was also sort of, I had encouragement from two of my professors. One is Dr. Neil Smith and then Dr. Rob Ewing. He was also my third year supervisor, and he supervised my bioinformatics project. And one very, very important moment what I'd like to mention, in May 2019, so just before I finished university, there was a symposium for machine learning. And I found out about some applications of machine learning into basically how can you use biological data and how can you curate data and so on, which made me basically, I was amazed on what can you do. And everything that was presented was actually some old research. So it was already a few years old, by the time it got to me and I understood the impact it had. And that's when I realized, okay, that's where I want my next step in my either studying or in my career to be, in something related to how to analyze data. I knew that probably I didn't have all the skills that I needed, but I knew I had the motivation. I knew I had a strong biological background, as well as a strong scientific background, if you want, which is very important. And yeah, that sort of went on with more seminars and more meetings, and basically meeting new people, meeting top researchers, which yeah was very, very, very exciting moments. And yeah, that cemented my decision to still be in the field, which I'm still now. So yeah, I'm really, really happy with that.
That's great. I wanted to ask, so how did you find your time at Southampton in a way? Like, how was your first year, when you moved in to like, by the time that you finished uni, like how was that experience overall? Because I know it's scary for like a lot of people that are applying. Like they think that uni is a massive, like big step that they need to take. And like, I just wanted to ask about that. I'm gonna direct the question first to Ian.
That's a very good question. So yeah, first of all, I was very, very scared. I didn't know what to expect. I was very excited at the same time, but I didn't really understand what was going on around me. And I was sort of in that state for the first couple of months, I would say. However, I must say that the support was there on any sort of area. First of all, my tutor and everyone at the university were very understanding, and they picked up on the fact that I didn't really have such a strong, let's say, maths background or biological background compared to the level that I should have been. That was no problem, because there are many, many sessions which can support either international students or home students who didn't have basically access to that specific area. Now, I had the opportunity to live in Wessex Lane Halls in my first year of university, which I absolutely enjoyed. And there's also lots of support in there as well, basically directing you for any issues you might have. The washing machine is not working, you have someone on site. And just to give an example, you have a pipe burst into the bathroom and there's water everywhere. You have someone you can call. And I think that's very important in the first year, at least, to feel supported and to know that someone is there for you, especially if you know that your family is far away from you or they can't reach you at the moment, which was the case with many, many people in my course. So yeah, the support was there, and I don't regret at all the fact that I lived in university halls. And also the community feeling at the university. So, for example, the societies that are available, the lectures, the free sort of lectures that are available as well on many different topics. For example, I remember seeing myself, it was probably in the first year, at the end of the first year or beginning of the second year, when I attended a lecture about volcanology. I knew nothing about volcanoes, but what I found really interesting is that without me knowing at all, that talk was actually centered on data generated from volcanic eruptions. So it sort of merged in my data science area without even me knowing. So my advice would be try and attend as many things as possible. And if you feel like you're struggling, there's always support around you. You just have to ask for it.
Well said. Because I also, like when you mentioned about like lectures and stuff, I think I remember like attending a cosmology lecture, and like I didn't know anything about it. My friend she does electronics like and engineering, so she knows a bit about it but not too much, but I had no clue, and I went into it not having a clue, and then by the end I was like, okay, I understand a bit of what cosmology is. So it's always good to like experience, like, go to things that you don't really go to, put yourself out there. That's so important. Again, I want to ask Jamie the same question, like, what kind of advice do you want to give in terms of like, how your first year went to, how, like, I guess the progress from then to like finishing a degree?
I would encourage everyone that wants to go to university, first thing I have to say, because I started university and as one person, quite shy, and left university a completely different person. My 4 years at Southampton set me up for life. And the first couple of months was hard, moving away from home. But you're there with other people that are also away from home. And you're there with people your own age who share similar interests. And being in that environment, it was hard the first couple of months. In the first semester of 2011, it was hard. being away from home. But I learned very quickly that actually everyone's in the same boat, and that a lot of people were feeling the same way, homesick, and that's okay. Because moving away from home, assuming that's what people on the call want to do, to go to university, you spend the first 18 years of your life, 18, 19 years of your life at home. You know, you get mum or dad to do the washing up or to wash your clothes. And actually, if doing that for the first time, it's like all these buttons on the washing machine. Do I put the money here? Do I, But you figure it out. And I'd say the great strength about university is that yes, you're there to do a course. Yes, you're there to learn about chemistry, and that's obviously important. But it's not the most important thing, I would say. The most important thing is to focus on putting yourself out there, doing different things, trying different things, because you're never going to get a chance to do it again, not to the same level. And if I could, the things I would tell myself now, as I turn 30, the things I could tell myself, Jamie at 18 compared to Jamie at 30, I'd say do more, get out more, talk to more people, go to more societies, go to this lecture, go to that lecture, because it's free. Not free, but you know what I mean. It's yeah. But you've got an opportunity to join as many societies or as few societies as you want. You've got an opportunity to go, if you want to go to a lecture on cosmology, go to a lecture on cosmology. Assuming it doesn't clash with your studies, go and learn about data science, go and learn about horse riding or fencing or history of art or I don't know, if you're in politics, go and join a political society. You've got the opportunity to do that. And the people that I've spoken to have come, because as I say, I used to do admissions. The people which gave me the chance to see people applying and people coming out the other end. And the people that I would say have been the most successful aren't necessarily the people that study the hardest, which although that's obviously important. It's the people that grew up the most. And by that, I mean they tried different things and they failed at some of it. They failed at a lot of it. Absolutely. But that's part of growing up. And it's hard. You know, it's yeah, so that's my advice. It's try it. Try different things.
I'm really glad you mentioned failure. That's something I would like to add a bit on. Yeah, fail as much as possible.
Yeah, please.
Well,
yeah.
Not to the level of failing everything, but yeah, I would say failure is good, especially at university. It's going to help you grow up very fast, and you'll understand basically that not everything is life. It's just rainbows and roses. At some point, at any other stage, you'll encounter failures, and failures at a big level. So yeah, I would say just go out there and fail as much as you can and learn from it, and just enjoy it at the end of the day.
Yeah, good, because if we can do it, if I can do it, anyone can do it.
I agree.
You know,
exactly. That's yeah, guys. That's literally like what life is in terms of like, you know, learning your lessons.
Yeah.
I do want to move on to the Q&A because I can see that a lot of you have. Wow, there's a lot of questions that are popping up. So the first, the most liked is there anything that makes Uni of Southampton better than other unis? I'm going to direct that to Jamie.
The answer to that question is, put it bluntly, no, there's not. It has to feel right. I don't know, that's probably not the answer you were expecting. You know, the universities at Southampton is all great and fantastic. A lot of Russell Group universities are more or less the same. They'll pull out statistics saying, "Oh yeah, we're top 3 or top 5 or something." You have to go to the university that feels right for you. The city has a feel. The university has a feel. The people have a feel. And by all means, please go to as many open days as you can, because it's only by going to as many open days as you can, by trying it. You know, go to, if you want to go to Warwick or Newcastle or Edinburgh or Belfast or overseas, try it. Talk to the people. Have a look around the city. Have a look around the campus. Does it feel right? And I mean, obviously Oxford and Cambridge are, you know, they're sort of in a league of their own, but a lot of the Russell Group universities, I think there's 20 or more, 25 of them, they are more or less the same. There are some maybe slight differences between teaching ratios or student ratios, but that's not hugely important for me. When I was looking at it, was are the students friendly? Are the teachers friendly? Do they get that, for example, you're moving away from home? Is there the support there? And Southampton felt right. And I think that's probably the most important thing. Does it feel right? Because you're spending 3 or 4 or 5 years of your life there. It's a big decision. So it has to. So for me, it had to feel right, and it did.
Absolutely. One of the questions is, where do you recommend getting work experience for chemistry? So this is in terms of like placements, internships. I'm guessing like for you guys, it's like personal statements. So like, what would you write like in terms of work experience?
Good question. It depends what you want to do, because there are so many opportunities to go. I mean, obviously, don't work down the local hairdresser if you want to go do chemistry. Although it's important that we have work qualified hairdressers, but that's perhaps why that perhaps won't prepare you for a degree in chemistry. I would say go and. Is there a local laboratory you could shadow? Is there a local power station? Because power stations, for example, Hinkley Point C. For those of you, if there's anyone on the call from Somerset, go and have a tour around Hinkley Point C. Go and talk to teachers. That was the most important, because teachers at A level at GCSE will generally have the links around the local community, and it might also be go and talk to your local university. Do they have opportunities to go and do some shadowing in their labs, assuming you want to go and do chemistry or biochemistry? Work experience is sorry, I know I talk too much. I'll shut up. I talk too much, I'm sorry.
It's fine, it's absolutely fine. I just want to ask the same question to Ian in terms of biochemistry, like what kind of work experience do you need? Did you do any internships or placements for that?
Yeah, so that's a good question. What I would advise first is once you get to uni, because probably the best way to think about it, once you got there and it's past the first year, let's say the second semester of the first year, speak to your lecturers, speak to your professors, speak to as many people as you can, speak to your tutors. They will be able to direct you to some work experience that you may be able to potentially do inside the university. So in my case, I have done a summer project, as I mentioned, with Dr. Neil Smith at Southampton General Hospital. And the way I found out, it was not advertised anywhere. There was no one who actually told me about it, but I just went from professor to professor, from lecturer to lecturer, and just basically found out lots of opportunities out there. I know there's also a platform for advertising internships at Southampton, internships and work experience. My advice is basically keep an eye on that as well, because you never know when there's an opportunity you might like. And also speak with your tutor or your mentor at university, because that's very important. They may be able to support you to get there, or at least to score an interview for that specific position or internship.
Can I add to that as well by saying that a lot of schools and colleges have a careers service, and that careers service will have links to local communities, schools, power stations, for example. So when I was, this was going back 2009, 2010-ish, I did a stint, I did a week experience at a local power station. I forget what it was called, but it was a gas-fired power station, and that helped me determine whether I wanted to do chemistry or environmental science. And I got that through the careers service at my college. So most colleges and schools should have a careers advisor. And ask. Yeah. Ask. Yeah, that's what they're there for.
Yeah, like I agree. I totally agree with that, because I think in terms of at Southampton, we do have like a career services which you can access to apply for internships and stuff, even graduate schemes. So when you are going to be graduating, you can apply through that platform. And there's obviously like Bright Network. There's like so many places where you can apply to certain internships and placement years. I'm just looking through. Okay, so someone's asked, how many hours on average do you have to study the 10 lectures or do lab work per week per day? And I think, yeah, in terms of like at university. So what did he guys, did he have a lot of lab work? I'm going to direct that question to Ian.
Well, that's a good question. I would say you have to do that as much as you're willing to, in the sense that there's no one stopping. If you want to study 20 hours a day, there's no one stopping you. If you want to study 5 hours a day, also there's no one stopping you, but it might affect your career path. How I like to think about it is basically every day that you're not keeping up with basically with lectures, with exams, and with all the knowledge that is being generated on a day-to-day basis is probably going to set you back at least a few months in your career path. The reason why I'm saying that is even nowadays in my current position, we're trying to keep up with the most recent advancements in the scientific field, and it's hard to keep up with them because every day there are like thousands and thousands of new things being discovered. It's quite hard to just categorize them. So in terms of the hour, because the question probably expects a defined answer, I would say start with what you're comfortable with and try and adding a bit more to that. If you feel like you need a bit more, let's say you're not very good at, I don't know, let's say genetics, for example, I would set aside, let's say an hour and a half a day, just go to those concepts and just try and understand them better. And if you don't, go back to your lecturer. That's why those people are there, not only to give a lecture and then go home, but they're available to you as well. Reach out to them an email, ask them after lectures, and I can guarantee you they will always try and support you the best they can. So yeah, that's what I can add to that. And in terms of lab work, my lab work was only sort of related to the first year, second year, and then the project I have done. However, I must say that those hours of lab work, which were probably about 4 or 5 hours a week, I think in total, really played a major role in my first position at Charles River, where I had to basically use all that knowledge from the lab side to understand all the issues on the data side. So yeah, I would 100% encourage you to not miss any labs, especially even if you're not planning to work in the lab, those skills are really going to come in handy.
Again, I'm going to ask the same question to Jamie.
So I treated it like a 9 to 5. So by that measure, 8 hours a day, 40 hours a week, minus lunch breaks, or let's say 37.5 hours a week. And if I could talk to myself 12 years ago, I would say don't work so hard, because you're there at university. Enjoy it. I mean, chemistry is a hard subject, and expect to spend the majority of your week, not all of your week, but the majority of your week, going over chemistry and doing science. In terms of the division between practical work and theoretical lectures, first year was about an afternoon a week. Second year was probably a day a week, day and a half a week. And then, because I did a master's project, my third year was a literature review. My fourth year I was in the lab fairly much full-time, full semester for the first semester. Second semester I was doing advanced chemistry lectures. Yeah, I'll keep that nice and brief.
For me, honestly, though, I didn't do that much lab work first year because of COVID. Second year it was a big step because obviously like how I didn't do as much. And then final year, I feel like I learned a lot through doing a project, and it was like quite intense because it was just 5 weeks of lab work. But I think I've learned like so much. So really, like you can like I only knew how to properly prepare in my final year. So it really, and also with lectures, it's all about working smart, not working hard. I always think of that.
Yeah.
Because it really depends on like, you know, how you organize your time. If you find certain things difficult, go through that stuff first. Don't go through the easy stuff. Like we all tend to do that. So yeah. Also, someone has asked about like the step from A-level chemistry to university level chemistry. Like how big is that? Is it a big step? Is it quite, you know, direct that question to Jamie.
To microphone back on. Can you hear me all right? It seems to be having a hissy fit. Yeah, there we go. Yeah, so different people, different colleges across the UK study different things depending on their exam board. Well, that's the way it used to be. I don't know how if it. I don't know if it's still the same these days, but I imagine that different people study different things. And the role of first year is to because some people do a bit of, for example, nucleophilic substitution, some people do a bit of quantum science, some people do a bit of organic or inorganic chemistry, some people do other things. And the role of first year is to make sure that everyone starts from the same base. So you'll cover things that you think are really easy. You'll cover things that you've never come across before. When I was there, I can't remember what my exam board was, but we did a lot of organic chemistry. We didn't do so much physical chemistry, for example. So a lot of my research, a lot of my lectures that I found the hardest in my first year was looking at things like pH diagrams. It was looking at spectroscopy. So the first year, the bridge isn't that big. It's designed to make sure that everyone starts from the same playing field, basically. And that when you start in second year, that everyone has a good understanding of the fundamentals so that you could then begin to specialize.
Great. Also, there's a question about biochemistry. Generally, what do you cover in a biochemistry degree? And that's directing towards Ian.
Yeah, that's an interesting question, because I would say it covers everything, and by everything, I must explain what I mean by everything. Basically, you need to get a small flavor of any sort of sub area of any life science, environmental science, anatomy side, potentially a small overlap with medicine as well. The reason why I'm saying this is in order for you to understand what sort of modules we'd like to choose in the second year, you need to get a taste of everything. In my case, it ranged from anatomy, physiology, hardcore chemistry, more directed towards the organic chemistry, because I guess that's a bit more relevant to the biological side, but not only limited to that. So as far as I remember, I also had a bit of physical chemistry in the first year as well. That was, of course, covered loads of elements regarding genetics, epigenetics, and basically how the genes influence the grounds of life. Macromolecules of life are covered as well. I guess proteins and everything which are building our blocks and our bodies need to be understood on a molecular level in order to apply something at a higher level. And finally, what I would like to finish with, and that's highly relevant to what I'm doing now, is basically the overlap with computers and data. Basically understanding how these core elements of statistics, and some people say that statistics and mathematics, they sort of overlap at some point. I think they're two distinct fields because everyone has their own applications, at least in my opinion. So I would say put a lot of accent on the statistics because those are really important. At some point, you may read some papers, you may read some, even in textbooks, you might find a specific p-value, for example, or any other sort of statistical insights, which you may not be able to interpret in a biological way without understanding the statistical grounds of what that specific affirmation actually means. So yeah, that's what I would say. And I would like to probably just finish touching a bit about understanding how can you apply all these methodologies, basically overlapping with industry standards. How can you analyze some data? How can you analyze some samples? How can you do PCR? How can you do DNA extraction, DNA purification? Basically, all the methodologies and all the lab machines that you may have to use in your further career.
Perfect. So someone has asked, is there any benefit of choosing biochemistry over chemistry or vice versa? This is going to be like the battle between the two sciences. Yeah, I'm going to ask Jamie first.
No. It's a short answer. Longer answer is it depends on what you want to do. Do you want to do something biological? Do you want to go into medicine? Do you want to go into data science? Do you want to work in virology? If the answer to that question is yes, then do biochemistry. If the answer to the question is no, and like me, you're not quite sure what you wanted to do. I just knew that I wanted to do chemistry. I didn't have a clue. Didn't have a clue what I wanted to do when I finished. I did chemistry because it was a central science. Because it covers it does, as I say, it covers everything from maths to quantum chemistry to a bit of physics. There's even a bit of human geography in it. Not very much, but there's some. So I did chemistry because it was a broad range. Biochemistry, I think, is more specialised.
Yeah, what I would like to
Perfect.
shortly add to that, probably the question lies in the fact that which one should you pick? I would say if you don't know which one to pick a random one and try and stick to it. If it doesn't work, you can always switch to something else. That's something which I've done. For example, when I've chosen the course in Southampton, yeah, it's basically if you don't know what to do, pick something, see if it goes on. If it doesn't go well, you can always switch to something else.
That's good advice.
Can I also add to that as well that if you do chemistry, you have the option to do a lot of biochemistry modules, because in your first, second, and even third year, even my fourth year, I was still choosing modules. And for me, I've never been a huge fan of biology, so I dropped biology as soon as I could. I focused on quantum chemistry and inorganic chemistry. But chemistry doesn't mean that you have to do pure chemistry. I know people that chose all their modules in medicinal chemistry and more or less did exactly the same degree as biochemistry.
Yeah, I totally agree with that. Like in terms of even doing, because I did a chemistry module last year, so you can, do biochemistry and choose a chemistry module if you'd like, even a bioengineering module, so it can go anywhere. Yeah, it's really important with like the modules that you choose, because there are some modules that if you want to do pharmacology, you can also pick pharmacology modules, or neuroscience, you could pick neuroscience modules, even if you do biochemistry. So if you want to like a taste of something new, like something different, you can always pick modules linked to that. I do want to end it there, guys. So I hope this event has given you an insight into where your chemistry or biochemistry degree could take you. We're very lucky to have had some fantastic speakers who have fascinating careers. If you've enjoyed this online event and would like to explore other career areas, make sure you sign up for our future events. Make sure you note this down in your diaries. Tuesday, 14th March, looking at where could your health science degree take you, and Tuesday, 21st of March, which explores where your degree in physics take you. All of the events, including this evening, has been recorded, so you can rewatch it anytime and view our other events too. I'd also encourage you to investigate our diverse range of courses, and we also have open days later in the year where you can come and meet our staff and students to find out more. If you're a current applicant, please look out for your invitation to our applicant visit days, which are coming up soon. Applications are also now open for a residential summer school, so please check if you're eligible to apply. Thank you so much again to our speakers, Ian and Jamie, and to all of you for joining us.
Thank you.
Thank you.
And attend open days if you get the opportunity. Go, please go. Yeah, go.